Hello, welcome to this version of my video. In this video I'm going to be showing you how to carry out analysis on a terrestrial image, specifically from a coal mine. And in this tutorial video I will be mentioning some other things that you can do apart from generating the particle size distribution curve. So I'm going to be talking about how to use the edit assist tool, the boulder counting approach in assessing your blast. I'm also going to be wrapping this video up with how to set specification envelope to track the material coming from the mine, especially when you're taking the material to the primary crusher. So you want to set up the specification envelope, which is denoted by a yellow curve on whip frag, to make sure that those materials that are coming from your blast site align with this particular curve. So the curve would define the coax version of the material from the mine, and the fine version, then the mean size, and also define the uniformity index of the material. More uniform or highly uniform materials are having a lot of advantage. The first thing is that it's improve the efficiency of your comminution operation, and also enhance the loading operation, because when it's uniform, it's easy to dig and easy to load. So let's get started. So in this case, I'm using a pointer scale. So there are different ways you can apply scale to your image. You can use reference objects by placing the objects perpendicular to you, and you can also use the laser scale, which is like a pointer scale. So you can see the green point here is showing the laser. So the distance between these two laser points in this case, in this tutorial, is defined to be 100 centimeters. So the first thing I'm doing is to set my scale, and you can also use the auto scale. The auto scale have a lot of advantages. One of the advantage of the auto scale is that it's make your image acquisition safer. You don't want to keep going on top of the muck pile. The laser scale also prevents you from going on top of the muck pile, but you need the laser scale equipment to make sure that you have the laser scale. You also need to calibrate the laser scale to make sure that you have equal distance points at any distance that you have. So in this case, I recommend using the auto scale approach in taking your image. It's faster, it's easy to use, and it's more safer. What do you need to use the auto scale? All you need is your mobile phone. Download the software, which is free. Install the software, and when you get to the site after your blasting, you want to pull up your mobile phone, either an Android mobile phone, iOS, or iPad of any version. You can download the software freely on our website, which I'm showing on the screen right now, and you can install the software. And when you get to the site, one thing about the software is that you don't need network coverage to be able to use the software on site, so it doesn't require internet. So you can use that for the auto scale. So here I'm going to be setting the scale. Let's do that together. The first thing you want to do is select the scale option, select the scale type, which is single. Then you put in the scale's length, which is 100 centimeters. So in this case, the distance between these two dots in real time is 100 centimeters. So you want to put your cursor and put your cursor on the first point. Then you left click and hold on to your mouse, then you drag to the other points. So in this case, we are done setting the scale. So the software is going to calculate an equivalent scale factor. So you want to lock the scale. What is the advantage of locking the scale? When you lock the scale, it's sometimes you might make mistake, or by mistake you drag your cursor, or you hold on to your cursor and you affect the scale. So locking the scale here will prevent you from tampering with the scale as you continue with your analysis. So the next thing I want to do is to generate the net, and in this case I'll be using the deep learning. So I'm using the deep learning in this case to generate the net. So we are done generating the net in real time. So I want to right click on the analysis to see the quality of the net. So in this case, you can see some part of the image is not included because the software don't make an assumption of what the length of this material is. So far the software can't see the complete edge of a specific material, maybe because the image is excluding this the edge of that material. So what the software does is to exclude that, so you can see some part of the image is not included. So it's more safer and good you don't want to underestimate a specific material, which will definitely affect your particle size distribution curve. So in this case, the software prevents that entirely. So continue with the analysis. Activate the heat map. So you want to activate the edit assist tool right here. In the first activation is going to show you the 50 biggest fragments, and you're wondering what the size of each of the fragments is. You can put your cursor on each of it and right click, and you can see what the size of each of the fragments is. So you want to also assess it based on size. So I want to see material that are bigger than 80 centimeter in this mock pile. So I put in my 80 centimeter and I activate that. So it says there's no material as big as 80 centimeters. So I want to change that to 50 centimeters. So I reactivate my edit assist tool, and it says this is the material that is bigger than 50 centimeter in this place. So you can see, so the edit assist tool help you to assess your blast, assess the boulder, count the boulders, and compare the material size to your payloader or your excavator bucket size. So in this case, I want to proceed. In another version of my video, I'm going to demonstrate to you how to use the color ID icon. What does it stand for, and how can you use this specific function to assess dilution? Most of the time you have issue of dilution in your mind, and you want to use this software to quickly assess the material size which are having high dilution, or the one with low grade, high grade, and the like. So this specific icon is what you can use to set a specific color ID. The color ID 1 will be the high graded material, then the color ID 2 will be the waste or low graded material based on color distinction. So the software is going to set a color profile for each of the material, and you can see the percentage of the material that falls in each color profile pockets. So I'm going to have a special video on that. So follow my my page, follow the WIP web page on YouTube, and stay up to date. So I'm going to be releasing the video in my next post. So stay up to date and learn how to use the software to control dilution. Now we're generating the particle size distribution curve. Here is the particle size distribution curve. In other scenario, what do you have here on this page? You can export this page as a PDF in form of reports, and another thing is that you can rename the blast. Maybe this is blast 1 from which mine? From pit 2 precisely. So you can rename that, and that will be exported alongside with your PDF report. So here you have the summary of the analysis. The D50, what does the D50 stand for? So I have a lot of people asking me question about this, what the D50 means, and what is the difference between the D50 and the D80. Some people also ask me question about what is the difference between the D80 and the P80, so or F80. So all these things are a bit confusing, especially for those people who are not familiar with image analysis, particle size distribution analysis. So the D50 in this case, as far as the software is concerned, is denoting the size that describe the 50% passing size. That is 50% of the material in this image is smaller than 248.33 millimeter. Then the D80 also connotes the same thing, that is 80% of the particles that are captured in that image that you are analyzing is smaller than 486.21. The same thing to D95. Then the biggest fragment, that is the biggest particle in that image, is denoted by the X marks. N stands for the uniformity index, that is the Rosen-Ramler uniformity index. How do you interpret this specific curve? You can interpret this curve or this result in different ways. I'm going to be having a special video on that also. I don't want to dive deeper on that, but in this case I just want to let you know that there is a specific tool here that can help you to interpret the whole results in quick time. So if you want to interpret this result, maybe your KPI factor or your consideration in analyzing this specific image is that you want to see the percentage of the material that is smaller than your crusher. So what you want to do with the DX2, the smart 2, is that you want to put the size of the primary crusher in the size bus. So if you put the size of your primary crusher here, for example, maybe you are using a very small crusher, and you put the size of your primary crusher to be 800 millimeters. So you see, the software is telling you that right now this image does not have any material bigger than 800 millimeter. That is, if this is for your 800mm primary crusher inlet. Then all this material fits into the crusher. You see how easy it is. So you can add additional parameters here by just right clicking, and you can remove one to add additional. So you see others are here, so you can have everything showing here as a summary, but you can always include whatsoever particle or class of material that you want to see on the summary box. Now let's go to the last part of this video, which is demonstrating how to set a specification envelope. Specification envelope is easy to set. All you need to do is to know those sizes that you are interested in and what you want the curve to look like. What is the actual curve that describe high efficiency crushing or high efficiency loading? So you want to set that specific curve. So you start with the highest. So you want to put this as 90 to 100, for example, as the max. Then you move to the next one, maybe 80 to 90 in this case. So you set the curve in a way that it suits your needs. So I'm setting this curve in such a way that it suits my needs. So in this case, I may jump to the next one. I said, oh yeah, I want to go down to 50, and here I'm going to 60, for example. Then I'm jumping here that I'm going back to 20, and here I'm going to 30. Then from here I want to go as far as minimum of 0 and maximum of 10. So I just set the specification envelope. So you can see the specification envelope follows suits on the curve. So here, how do I interpret this specification envelope? Right now I have my specification envelope showing that I have undercrush that is more of material smaller than my size specification. So what happens if the curve, that is the blue curve, which is the actual curve of this material, falls behind the specification envelope? The implication is that most of the material in this blast is smaller than what we want, that is, we are over blasting. Then what happens is if the particle size distribution curve falls within the specification envelope, that means we are blasting up to our optimum size, that is, each of the material size in this blast is meeting our requirements. Then what happens if the particle size distribution curve falls below, that is, it falls within this region? Now we have it above, that is at the top, behind. Then that means we are over blasting the material. We have more of overblast material. In this case, you are wasting more of explosive. You want to adjust your burden and spacing and cover more of the material and reduce the explosive energy if need be. Then what happens if this curve falls in this particular region, that is below the specification envelope? That means that the blasting, you are under blasting the material, that is, you are using lots of explosive energy, and as a result of that, you have more coax material, that is, you have more of boulder, and you have less of the material meeting your specification. So that is how to use the specification envelope. As I've said, you can set the specification envelope using different sizes. I always recommend using sizes like the primary crusher inlet, the secondary crusher inlet, the size of your loader, that is the bucket of your loader, and other sizes like the bypass size of your crusher, among others. And if you are more sensitive about the grade of the material, you want to select the size also in this particular size in setting your specification envelope, the size that supports high recovery rate during your material sorting or material separation. Yeah, thank you very much. As I've mentioned, I'm going to be doing 2 separate videos for interpretation of the report entirely. So I'm going to be covering more of the report, showing you how to interpret the histogram, showing you how to interpret the this specific box right here, and also showing you how to interpret the curve completely. Then another video that I will be doing in my next post will be a video that explains how to use this software to track your dilution rate, that is, to track how much of the low grade material you are having after your blast. Thank you very much for watching this version of my video, and I look forward to you commenting and liking the video. Let me know what aspect of the software you like to learn more, then I can do a video version to cover that for you. And also, if you're having issue with your fragments blast fragmentation assessment, you want to share what you're passing through, then I can show you how the software can address your specific needs. Thank you very much, and have a wonderful day. Thank you. Bye.